Okay, part one. With a concave mirror, what type of image do I see projected? Is it real or virtual? Is it upright or inverted? I see a virtual reflected image that is inverted, as you can see. As you can see here. Let's move it away from the mirror and see what happens. So when I move the image away from the mirror, the reflected image moves closer and closer to the focal point while simultaneously shrinking. It gets smaller and smaller and smaller. When I move the object near but not touching the yellow focal point, let's see what happens. Near but not touching, as you can see, the reflected image moves away from the mirror and gets bigger, gets larger. So it does just the opposite, in fact. Let's move the object so it's midway between the focal point and the mirror now. So we're going to move it here. And as you can see, that image now flipped so that it is on the other side of the mirror, on the same plane. It is no longer inverted, but it is still a virtual image. So, interesting. Okay, part two. Let's change this mirror to a convex. A convex mirror. Now the focal point is obviously inverted, right? So your focal point switches sides. When it's on concave, it's on this side, and convex, it's obviously opposite because it's just reversing that. So, all right, let's start with the pencil far away from the mirror. Clear back here. And then what type of image do I see? Is it real or virtual? Is it upright or inverted? It is a virtual image still. It's not inverted. It's upright. And it's a teeny tiny little image. Let's move towards the focal point now. Closer and closer to the focal point. As you move closer to the focal point, the image on the other side will get bigger and move closer as well. This reflected image is moving closer and getting bigger. Now we move the object so it is midway between the focal point and the mirror. Midway between the focal point and the mirror now. So if we move it to where it's midway between the focal point and the mirror, the image is about half the size, and it is still upright. Okay, part three. Let's change this mirror to a flat plane. And here you can start to see things are going to look a little more symmetrical here. So let's start with the pencil far away from the mirror. Let's move this far away. And what you see as it moves further away is it starts to fade out, but it remains the same. It doesn't change. And then let's move the object a little closer now. So we're moving this closer, and what happens? The exact reaction happens. This moves closer as well. How does this affect the location? It moves closer in, mirroring this image. The magnification equals out. So the distance this one is from the middle, the scale of the image correlates, but the scale doesn't necessarily change. So, all right, let's answer these three questions. What types of images are created by concave mirrors? When is the image real and when is it virtual? Well, let's go back to concave. We're back to concave now. As you can see, when it's far away, it creates a virtual image. But as you move it closer, it's no longer a virtual image. It's a true image, like a regular mirror would be. Obviously, the scale is bigger on the outside of the concave, on the convex side. Question 2, what types of images are created by convex mirrors? Well, let's go back and look at convex. So as you move this away, the concave side of the reflection gets smaller and smaller and smaller. As I move this closer, the concave side starts to get a little bigger, closer to the actual image. Question 3, what types of images are created by plane mirrors? Well, let's go back to plane mirrors now. I think it's pretty obvious with plane mirrors. We're all kind of used to a regular plane mirror. It is symmetrical. It mirrors exactly what is on the other side. What is the relationship between the object distance and the image distance? It's relative to each other. They're equal.